Good morning, friends. In the last period, we have studied about the topic number 3. In that is magnetostatics. We have discussed about the magnetic flux, magnetic field, and magnetic induction. Biot and Savart law. These articles we have to discuss in the last period. In this lecture, we are going to discuss very important derivation for the magnetic induction due to the straight conductor. This is a long straight conductor we have to consider here carrying a current, and long straight conductor, a long straight line wire on the x-axis from minus infinity to plus infinity. Here boundary we have to consider minus infinity to plus infinity, and here the current carrying conductor having current is say I, and in that we have to say that a length element, this is the length element that having length is say dx with the length of the element. Let p be any point at a distance is what we have to say small d, and we have to say that this x-axis we have to consider another say angle made by that factor is say theta, and because this total angle is considered as say this is say pi, and this gets what we have to say that this is theta, so remaining angle this can be considered as say pi minus theta. This is what we have to say that pi minus theta. This angle is say pi minus theta because the whole angle is say pi. So from the according to the Biot and Savart law, magnetic field due to the current element I dx at point P, according to the Biot and Savart law, that is dB is equals to mu 0 upon 4 pi I into dl की जगह आएगा dx sin of theta divided by say r square. This is according to the Biot and Savart law. We have to write that I dx sin of theta divided by r square into say k cap. K cap is say unit normal vector, and this is considered as say dB bar in the vector form. So k cap is the unit vector along the dB bar. This is where what we have to say that dB bar. dB bar is nothing but what you have to at a point say P, and along that we have to consider the normal vector say k cap. The magnetic induction at point P due to the whole wire is given by that is B is equals to integration of say dB bar, and that is nothing but what we have to say that mu 0 I upon 4 pi and integration of dx into sin of theta divided by say r square, or we have to say that sin of theta into say dx divided by r square, and here boundary conditions are minus infinity to plus infinity, equation number say 1. Now from figure let us say we have to consider say x by d means what you have to say that is this angle, this is say adjacent side and this one is say opposite side. Adjacent side upon opposite side means what you have to say that cot of pi minus theta is equal to x by d. Therefore x is what you have to say that length of the element, and then we have to write that cot of pi minus theta is nothing but minus cot of theta, and that is equals to say that is x by d. Differentiating what is the derivative of cot? Cot is nothing but what you have to say that cosec square theta, and then this can be written as dx is equals to d into cosec square theta into d theta. Then dy and sine of pi minus theta sine means opposite side, by hypotenuse, that is nothing but d by r, and then we have to say that sine of pi minus theta is a what we have to consider trigonometric identity. Sine theta is equals to d by r. Substitute this value in equation 1. एक नंबरच्या इक्वेशन मध्ये जर हा व्हॅल्यू टाकलं तर काय होईल? b इज इक्वल्स टू μ0 I अपॉन 4 पाय इंटिग्रेशन मायनस इन्फिनिटी टू प्लस इन्फिनिटी. dx ची व्हॅल्यू काय आहे? दिस इज द dx व्हॅल्यू, that is d into cosec square theta into d theta. Sin theta is d by r, and then divided by r square. This is the substitution we have to consider, and after that d theta having also one more value we have to consider here. B bar is equals to this k and k cap as it is, μ0 as it is, I as it is, 4 pi as it is. Integration changes from 0 to pi. So 0 to pi sin theta as it is we have dx की वैल्यू क्या है? Sin theta as it is, and here sin square theta divided by d square into d cosec square theta into d theta. Here this can be cancelled, and this is nothing but cosec square theta and This gets cancelled with this one because sin square theta is nothing but cosec square theta. And finally remaining thing is that b bar is equals to k cap mu 0 I upon 4 pi and bracket में रहेगा 0 to pi sin of theta into only d theta. Here we have to multiply the factor, what we have to say that this one, and finally it gives that nothing but this can be written as b is equals to k cap mu 0 I upon 4 pi d into mu 0 I upon 4 pi. Here d is there, and derivative integration of this one is what we have, minus cos theta, boundary condition 0 to pi, upper boundary minus lower boundary, it gives that mu 0 I upon 4 pi d, k as it is, and this can be written as 1 plus 1, and finally this gets that b is equals to mu 0 upon 4 pi bracket में 2i divided by d into k cap. This is the important formula, or b is equals to mu 0 I upon 2 pi d. This is the formula for a magnetic induction of a straight conductor. Again, we have to write that if point P is near the one end, then we have to write the formula for magnetic induction. B is equals to mu 0 I divided by 4 pi d. Mu 0 I divided by 4 pi d. Magnetic induction on the axis of a current carrying a circular loop at the center of the circular coil. This can be written as, one more formula, at the center of circular coil. We have studied in the 11th standard, 12th standard, that is B is equals to mu 0 Ni upon 2a. This is the one more formula for magnetic induction. Remember, all these formulas are very important for the magnetic induction of a straight conductor, circular coil. This is for circular coil and it is near one end, magnetic field. Remember the formulas, that is mu 0 upon I upon 4 pi d. Multiple choice related question may be asking on that. And then lastly, magnetic induction on the axis of solenoid having formula is, this is the formula for magnetic induction on the axis of solenoid. For solenoid, remember the formula. This is the formula for solenoid. If theta 1 is equals to 0, cos 0 is considered as say 1, and cos pi is what? Minus 1, minus minus plus 1. So formula becomes B is equals to, we have to write that B is equals to mu 0 Ni upon 2 into 2. 2 gets cancelled. For solenoid, mu 0 Ni. B is equals to mu 0 Ni. Upon 2L, na? Sorry, here 2L. L. This is the formula for the solenoid we have to consider. If the point P is at one end, B is equals to mu 0 n I upon 2. वन एंड जर शब्द आला तर रिमेंबर द फॉर्म्युला mu 0 n I upon 2. This can be taken as the center of the long solenoid. This is center of long solenoid and this is for one end. Mu 0 n I upon L. N by L is nothing but small n. And this can be also written as mu 0 n I. Thank you.